Okay, I'm going to show you how to do 5, 6, and 9, and you're going to do 7, 8, and 10 yourself. Okay? Now what's different here than before? No common denominator, right? So we have to think about 5y and 6. Okay? Do they have anything in common already? That's the first thing you should check. No. I mean, 5 and 6 are relatively prime. Yeah, they both have a 1, right? Like, let's say this had been a 3 and that'd be a 3. Or if this was a 3 and this was a 6, then they have more in common because 3 goes into 6. But there's nothing in common with those. So what I usually tell kids, I'm going to rewrite it. Sometimes we do break 6 into 3 and 2. There's no purpose because there's no 3 or 2 here. Okay. Now, one thing kids get confused about is you could reduce before you add. Can I reduce 3 over 5y? No. No. 4 over 6? Yeah, that's a numerical fraction. We have an algebraic fraction plus a numeric fraction. So what does 4 over 6 reduce to? 2/3, right? Okay, you want the denominators to be the same. So then you start asking, what does 5y and 3, the smallest numbers they'll go into is 15y. Does that make sense? Another way to think about it is if you give this one a 3, now they both have a 3, right? And if you give this one a 5y, and I wouldn't always, some kids just always do that. Like if this is a 3, they give both these a 3, if that's a 5y, they give both those a 5y. You could do it that way and it always works, doing it that way. But if you don't stop and think about it first, you could end up with some really large fractions. Okay? So we have 9 over 5y times 3 is 15y plus 2 times 5y is 10y over 15y. Common denominators, now I could add them. So I get 9 plus 10y over 15y. Okay. And maybe even go a step further and put that in standard form, 10y plus 9 over 15y. You know, I'm not too worried about that. Does this reduce any? It does not. So this is your final answer. Just out of curiosity, even the answer key left it like this. I think it looks better as 10y plus 9 standard form, but technically that is still fine. Okay. I'm going to put a little line here. No. You cannot cross off the y's because this is 9 plus 10y. The factor is 9 plus 10y. You have to have a 9 plus 10y here. Okay. Number 6. How about 6a over 6ab squared? Let's reduce before we do anything. Does anything cross off? No, I'm going to actually just, it's good practice because you always want to keep the original problem. It's good practice to just copy it again. That way you can see what the original problem was, because when you start crossing things off, you kind of lose track of the problem, right? So look at this fraction. Anything reduce? 6 and a are separate. 6ab squared are separate. No plus sign or minus sign. So it cancels. A 6 and an a, right? So what does that leave? Close. Right, there's always a 1 there, right? So it's 1 over b squared. What about here? Cross off the a's. 6 over 4 reduce? 3 over 2? Okay. And now b squared and 2, do they have anything in common? One's variables, one's numbers. Of course not. So what do you think you're going to do? Have we simplified this? Have we combined it into one fraction yet? No, so we're not done. So what does b squared need? If we're trying to make these the same? A 2. And what does 2 need? A b squared. Okay. So I have 2 over, and we always put the number in front of the variable, 2b squared minus 3b squared over 2b squared. Now what I used to do as a student, I would say, oh look, I could cross off the 2. And then I would end up with 1 over b squared, and I have to put a 2 back on, then I would cross off the 2, then I'd put a 2 back on, and then I'd cross out the 2. So even though these cancel, you don't want to reduce it because you want these to be the same, right? So my final answer would be 2b squared, and this would be 2 minus 3b squared. Does anything reduce? Can I cross out the b squareds? Because 2 minus 3b squared, right? You can't cross off the b squareds because that's what this is all together. So it's reduced, okay? That's it. And when you have all this work, it's always a good idea to box it in. And if you borrow space for a problem, usually people like to, just for their own benefit, I used to do that all the time because I had to borrow space. And if I run completely out of space, then I just put this on a different piece of paper and staple it and say, if I do that, then I'm going to say on a different piece of paper so that when the teacher's grading, they don't mark it off, right? All right, we also said we would do number 9. Pay attention to the sign. I almost thought that was a divide sign. It is definitely a plus sign. So 2 over 3, does that reduce? Huh? Yeah, you got to pay attention with division and plus signs. Okay, I know all this sheet is plus and minuses, but sometimes I've added when it was really a division. What about here? Does anything reduce? Well, isn't 6 3 times 2? So couldn't I cancel the 3's? Now you don't have to reduce before you add and subtract, but if you do, it is so much easier, believe me. So I get plus 2 over n plus 4. And I don't need parentheses. Okay. So 3, n plus 4, do they have anything in common? No. So what do you think 3 needs? And n plus 4. Should have left myself more room. Whatever I do to the bottom, I do to the top. What does n plus 4 need? 3. A 3. Now pay attention, I can't just put a 3 like this. Why? Because the n plus 4 is together, and if you write it like that, it looks like n plus 12. So you need to make sure you use parentheses, okay? And then, but a 3 here is fine because 2 is by itself. You don't need parentheses. Simplifying, I'd get what? Well, let's go ahead and write down what we have. We have common denominator, right? And you might do more than one of these steps at a time. I'm just showing you all the steps for the notes. So I'm going to write down 2n plus 4. And then plus 2 times 3. Let's go ahead and do that part of 6, right? All right, and maybe you distributed in that step too. So here, I need to simplify this. So I need to distribute 2n plus 8. Now before I said don't distribute. Why is it different now? Okay. Like if I just had this, if I didn't have a plus 6, I would leave it like that. In fact, I would cancel out the n plus 4s. Right? But because I have a plus 6 and the 2 times 4 makes 8, simplify would mean I would take 8 plus 6. Okay? So 2 times n is 2n. 2 times 4 is 8. And then plus 6. All over 3 and plus 4. Now the denominator you never distribute. You just leave it like that. Okay? But if you want to distribute, you can. Sometimes on the AccuPlacer, they'll write that as 3n plus 12. I personally think it looks better like this. Okay? Now anything combined? 2n plus 8 plus 6? 8 and 6, which makes 14. Now, can anything factor? We already know this is factor. Does 2n plus 14 factor? GCF of 2, leaving n plus 7. And a lot of times, what will happen is like this will cross off with that. It just so happened our problem didn't work out that way. So because nothing crossed out, you could have left it like this and still got full points because nothing crossed off. But the best answer is everything factored. So nothing crosses out, can't factor anymore. So that's my final answer. Now I want you to try 7, 8, and 10. If you wrote as big as I did, you might have to put some of those on a different piece of paper and staple it and put on a different piece of paper. And so I want you to try 7, 8, and 10, and those are the answers you should be getting. Something that looks like that. Okay?